Morning. Am I audible to you guys? Am I audible?
Yes, ma'am.
Okay. Let me share my screen first. Okay, I guess in last class I gave you guys homework to find the complexity of these three statements. So anyone tried? Have you tried this one? Complexity for these three? So answer for the first one. Okay, total time was okay. Then for the second one. Okay, second one, N. Okay, third one, third one is not O. Anyone else try the third one? Yes, it's O power N square. Let me show you some shortcuts how you can find complexity of any piece of code. Means there are certain time complexity for normal loops, then nested loops, then we have if else statements and all. Okay.
Ma'am,
See.
what will be the time complexity for that first one statement?
1, O1, so it will be a constant term.
C.
No, you already wrote O1, right? Just O1.
Oh, okay.
Hello? অলপ পাছতহে মই ক্লাছ কৰি আছো ঠিক আছে Can you see the whiteboard? Normally in programs, what are the main codes we have? We normally use loops, we use conditional statements, and so on. So just by looking at the piece of code, you can just think about it, what can be the possible complexity, time complexity, or the running time for the program. Let's see loops first. Okay. So what is the basic structure of a loop? Loop you can represent one example, less than equal to n. Then there is a statement. For example, just think it like equal to a plus b. Okay. So this is a normal single for loop, right? So what will be the time complexity? You can calculate it like number of times in for loop into time for the statement. Okay, so this will be the total complexity. Okay. For this part, I guess I already explained how you will calculate the time complexity. There are 3 assignments, right? So 3 constant time, and it will run up to n plus 1. Okay, so but then what about this part? This part will run for n number of times. Okay, until and unless condition is true, this one will be executed. So this part is like your constant time, right? This is a constant time. Okay, and this part will take, for example, n number of times. We are going to ignore that. Suppose n plus 1, we ignore this one part, so n will remain. Okay. So this part you can represent as c into n. Right? This is a constant time and n part. So what will be the total complexity? This we can represent as on. We will simply ignore this constant term, so complexity is O. Okay. So in your program, if you see any for loop, the complexity for that particular piece will be always O n. Okay. Next we have nested loops. So what happens in nested loop? What's the structure? For I, for example, just thinking about where do we use nested loop? Mostly we use nested loop for two-dimensional arrays. 1, 2 nested loop. 3 plus 6. So this is the basic structure. Right? Let's write a set. So what will be the complexity here? This is a constant term, right? This will take constant. So constant term means it's going to take like maybe 2 or 4 units of time. This one will be executed for this for loop, inner for loop, 2 times, one for assignment, one for the addition part, so total 2. Then for outer loop, again there will be another 2 times, so 2, it will be like 4 units of time. Okay, but anyways, it's a constant time. This for loop will run for n times. Okay, similarly, this for loop will also learn for n times. In case of for loop, we always multiply. Okay, multiply. So what will be the complexity? You can represent as n into n for loops. Then c, you can say cn square. Then we will ignore this constant term. So complexity will be O(n) square. Okay. So in your program, if you see any nested for loops, the complexity, the running time for that particular piece will be O(n) square. Okay, is this part clear? Nested loop. Everyone? So if you see in your program, if you see there is only one for loop, remember the complexity for that piece of code will be O(n). Okay. And if there is a nested loop in your program, then running time will be for that piece of code will be O(n) square. So do you get the idea how we calculated this n part and all? For loop is already clear, I guess. I'll explain last time. So in case of nested loop, just remember for inner and outer for loop, we just multiply both terms. So outer inner will run for n times and outer will run for n times. So n into n, n squared. And whatever statement is there, that will run for constant amount of time. So we are going to ignore the constant term. So the running time will be O(n) squared. Okay. If you have any confusion, ask directly. Later, when in Viva I am going to ask question and you are not able to answer, then it won't be good for you guys. Okay, so two loops done. So see, in our program, it can be combination of both statement loops and all. So how we are going to calculate that? Of course, consecutive statements. Let's say just we have like 3 lines and we are going to do like additions. First line is a equal to b plus b, for example. Next, I am using another one for loop. One that is still equal to n I plus plus. Then here I'm going to do some, for example, it can be any state. Okay, doesn't matter. Now you know, right? If you say for loop, no matter what statement is inside the for loops, the complexity for that for loop will be O(n). Okay. Next, for example, we have another for loop. It is also possible, right? You are using for loop in different places in your program. Okay. So here will be another statement. Okay, so just for example, this is a whole piece of code. In first line, it's an addition. Then I have another for loop. Then I have another for loop. Now you know any for loop, it will take n times. So this will run for n times and this one will run for n times. Okay, and this is just a constant part. This is also a constant part. First line is also a constant. It will take unit 2 times. Addition, and assignment. 2 units of time, correct? So it's a constant term. So let's consider this is C1 constant. Okay. then this part is going to take C2 constant. And this part is again going to C3 constant. So here you will simply add up all the complexity or the time taken by the piece of code. Okay, you will simply add it. Means in any program, you will simply add the complexity for each of the lines. So first line complexity is C1. Next line, so whole loop complexity will be C2n. Okay, then you will add up the last line. So here it will be C3n. Right? So this again you can represent, you can just combine this C2, C3 plus C3. Okay, so anyways, it's another just a constant term. And we can neglect. Okay, again neglect this part, so complexity will be O n. Okay. So in your program, if you need to find the running time, you have to add up running time for each of the lines. Okay, each of the codes. So first line will take constant time. Here I have another for loop, it will take another constant term. Then here I have another for loop, it will take n time. Now for example, you have another nested for loops here. Okay, same program. Suppose this is not a single for loop, it is a nested for loop. So what will be the time complexity for this one? Just the last one I'm changing. C3 n square. Nested loop means complexity will be n square. Okay. So now it's a bit changed. Here our whole thing is mainly dependent on n part. N is nothing but your input size. Okay, and mainly depends on the input size. So in this case, the complexity for whole program, you can represent just for example C2n plus C3n square. But again, we are mainly concerned about this two part. You can consider it n square. Okay. So whichever part will give you the highest time, means maximum time, that will be the complexity. Is this part clear for everyone? Let's see for a while. This part clear or not? Do you want me to repeat again? Okay. See, so in last two column. Okay. So here is a whole program. Okay. So in your first program, you have one line. So you know this will take constant amount of time. Like mainly it will take 2 units. How 2 units? You remember every assignments, every logical operations, every mathematical operation, and the return types take a constant or 1 unit of time. So in this particular piece, this addition will take 1 unit of time, correct? And this assignment operation, whatever value is there, we're assigning it again to the A, right? Again, it will take 1 unit of time. So total unit of time, right? So 2 is what? It's a constant term, right? Doesn't matter whether it is 2, 3, 4, 5, 10. Doesn't matter. It's a constant term. It's a number. Okay. So basically, it's not depending on your input size. It's just constant number. It can be 1, 2, 3, 4, up to 10, any number. Whatever it is, it's a constant term, right? It will take constant time. So you can represent it just like C1. You can give any term. Doesn't matter. It's a constant time. Okay. Next in your program, we have a for loop. Okay. So for loops you already know. I already explained 3 assignments. So 1 unit of time, 1 unit of time, and 1 unit of time. Okay. That means 3 unit of time plus n is there. The cost is 3. Cost is 3. Remember last time I showed you there is a cost and the number of times. So cost is 3, but loop will run for n plus 1 times. Correct? So it is 3n plus 1 time. Again, there are constant terms, so I'm going to keep only the n part. Okay, so loop is going to run for n times. N is the number of size. So if input size is 10, for example, you are searching in an array and the array size is 10, so loop will run for 10 times. Right? If your array size is 5, loop will run for 5 times. Okay? So since we don't know the size, so it's a n term. So it will run for n amount of times. So what is the statement inside? It's again one assignment and one, so 2 units of time. So again, doesn't matter what's the thing, it's a constant term. Okay, so inside the for loop, whatever is the statement, whatever are the lines, doesn't matter, it will be a constant term. So ultimately for this part, it's a cn time constant into n number of times. Okay, so again next, I have another for loop. Okay, so again same logic. This one will again take cn amount of time. Okay, so what will be the total time for the whole program? So what you will do, you will add up the time for each state or each line. Remember in your program you have certain line numbers, right? If you find any error, they will show the line number, right? This line has some problem. Okay, so if in this for loop, you can say like this is a third number, this is a fourth number, doesn't matter. This whole for loop is going to be considered as a piece of code. Okay, so this is a single statement, constant time. Then we have another for loop inside here. So it is taking cn time and have another for loop. So it will again take cn time. So what you have to do, you will simply add up all the timing. Okay, just to distinguish, I'll just give names 1, 2, 3. Okay, so this one means you are just adding up, right? Suppose this is 5 and time, this is 5 and time. So if you add up, it will be a 5 and time, right? So it's the same thing. For example, this is just 5 and. So total complexity, again, we always remember we will neglect the constant terms. So total complexity for this piece of code is O n. Just add up. Okay. In nested for loop, since this is there is like inner and outer loops, therefore we multiply. For any nested loop, time complexity O(n) square. So in your program, for all these, after all these, if there is a nested for loop here, just think there is a nested, there's another line, nested for loop or nested for loop. Okay, doesn't matter what's inside. So the moment I'll see nested for loop, I'll see the complexity will be Cn square. Okay. Again, same thing, you will simply add up all these things. So total complexity, if there is a nested loop, C1, C2, and C3, and plus C4n square. Okay, so then you will just add up the numbers. You can represent it like C1 C dash n plus C4n square. Okay, so again we are going to neglect the constant terms and also the part that is not contributing or exponentially increasing the timeline. O(n) square is what? Is the worst case, right? So for that we will consider this O(n) square part. Okay, so most of the time, whenever you see there is a for loop inside your program, then it is mostly like n. If you see there is a nested loop inside your program, most of the times the complexity is simply O(n) square. Is this clear? Okay, there is a catch. There is again a logarithmic complexity in case of for loop. Right now I am saying in for loops, it takes constant amount of time. Correct? For any for loop, whatever is the statement, it's always constant amount of time. Correct? But there is a change in case of divide and conquer operations. Okay. In divide and conquer, okay, this is I say logarithm. Like your binary search. In binary search one, we get the complexity log n. Show it how we get it. So in logarithmic complexity, what we do, algo simply is divided by 2 for each operation. Okay? So in divide and conquer rule, everything is same, just that all the operations are divided by 2. In binary search, we always divide the whole array into 2 halves. Okay, there are some sorting where you divide the array into 2 halves. So in case of logarithmic complexities, if you see any algorithm which involve divide and conquer, the for loop looks something like and there can be anything. Okay, and you can say there is a statement I equal to I into 2. Okay, so in this case, it will take log n time. It will take log n time. So total complexity sometimes it depends. Okay, what's there? It depends. Here I'm not mentioning whether it is I plus plus or not. Okay, in all these for loops, I mentioned it's simply increment I plus plus. In divide and conquer, it's slightly different. I'm not writing incrementation here. I'm writing incrementation will be twice I. Okay, here increment function is null. I didn't mention how it is going to increment. Okay, so that increment part I have mentioned here. I will be increased by twice of I. Okay. When I'll show you the binary complexity algorithm, then it will be more clear to you guys how we calculate. Okay. For the time being, just remember any algorithm which involves divide and conquer approach, most of the time log n is okay. Log n. So this part clear, I guess. Consecutive term. Okay. Next, see if else statement. Sometimes we also have if else statements, right? These are just conditionals. If else. So what happens in if else? Normally we have if, then there is a condition, right? There will be a condition, maybe I less than 5, I less than 2, anything. There is always a condition. This is the basic structure. If, then there will be a condition. Okay. Then inside if, there can be any statement again. Correct? Doesn't matter what is the statement. Okay. Sometimes if it is like simple uh, statement, maybe just normal statement, it will simply take a constant time. Right? It will simply, if any statement, it will simply take normal time. Okay. And so if it is n, it will also run for n number of times. Okay. Because it will depend on the condition. Now, if inside here, if there is a statement like for or something, then also it will take simply n amount of time. Right? Now, after if there is a else part too, right? There is a else part too. In else also, for example, there can be any statement, right? Inside L, you can say there may be one for loop. Okay, if there's one for loop, time will be on. Okay, if inside here there is a two for loops, means nested loops, then complexity will be n squared. Right? So what will be the total time for if else whole statement? You will simply add up these values. The complexity will be on plus on squared. So in worst case, we will consider only on squared. So if part will have certain amount of time and else part will also take certain amount of time, and you just need to add up that time. Okay, so this time will depend on whatever statement you have inside here. If it is single time, means single assignment and all, it will take constant time. If there is a for loop involved inside the if statement, it will take on time. Whatever it is, then again else part will be there. Same thing. You just need to add up the timing for both if statement and the else statement. Okay. So in this case, I just considered in one if statement there is a for loop. Then another one there is a nested for loop. So total time is I will add on plus on square. Okay. Before that, you can simply write, suppose this is taking C1 and C2 and square. Right? So here I'll take just C2 and square part and complexity will be square. Okay, so in this way, you can just look at your program and you will be able to find out the complexity. Next, when we will write the programs in lab class, you will see how we can calculate. Okay, mainly in most of the programs we use for loops. If else statements, there will be always consecutive lines, nested for loops and all. Okay, so there is certain which one is better. If some algorithm is taking constant time or one time, then this is always the best one. Any algorithm which will take constant time or one time is the best algorithm, or you can say the fastest. The worst timing is O1. O1 is the fastest. Then comes our O log n. Okay, then comes our O n time. So log n time is better than O n. So remember, your linear search program takes O n time. and your binary search program takes log n time. And binary search is faster than your linear search. Now see how we find it. Binary search takes log n time and this takes linear takes O n time. Therefore, we can see that why binary is faster than the OM. Okay. Then in some places, you will also see n log n. Okay, n log n normally we get in terms of merge sort. Sorting algorithm, there is a merge sort. In merge sort, the complexity is n log n. Okay. Then we have also exponential times like O(n) squared. So if any algorithm is taking O(n) squared, that one is not that very fast. Okay, this is like hierarchy. So this is your constant time, constant notation. This log n is your logarithmic. This O(n) is your linear time. Okay, constant time, logarithmic time, linear time. N log n is simply n log n. Okay, and this O(n) squared is your exponential. Sometimes you will also see NQ. Okay, in some algorithm you will see ONQ time is NQ. So this
মেম সাউন্ডটো অহা নাই আপোনাৰ ফাঁচি আহি আছে
hello, audible now. This is we can also see. Hello, audible.
yes ma'am yes
Also say quadratic, like your quadratic equations. Okay. And so this is like hierarchy. O(n) is better than log n. Log n is better than O(n). O(n) is better than n log n. N log n is better than O(n) square. And O(n) square is better than O(n)Q. And so on. Okay. Go through this a bit. We will be able to find the complexity. These are some small tips how you can calculate the complexity. Okay. This will come handy. Then you don't need to find the complexity like how much time it is going to take for assignment, how much for the logical operations, how much for assignment and return, and so on. Okay. This thing is going to end soon. Stop sharing. Is there any class now? Next class के क्या से बड़े question? Next class क्या से तुम्हें is the next class?
मैम 11:15
क्योंकि एक्स्ट्रा टाइम আছে मैं linear and binary substituting by দিম Do you want
মেম আকৌ ৰিজইন কৰিম নেকি মেম?
this to end কৰি লওঁ after 5 minutes start কৰিম বেছি নাই এইখিনি linear binary search তো already জানাই just want to show the complexity part okay so I'm going to end the meeting so after 5 minutes I'll start